Hello all. I welcome you on behalf of Edureka for mastering Git and GitHub course. Throughout this course, we have different modules designed to give you the complete expertise over the Git concepts and its applications. We'll be starting with the introduction to Git, and by the end of this course, we'll be completing it with the different Git plugins, especially with the IDE Eclipse. We are starting today on the module 1, which is Introduction to Git. In this module, you will learn about what is version control system, why we need version control, types of version control system, and advantages, disadvantages of traditional VCS. You will also be introduced to the basics of Git. Are the objectives, as I said. We're starting with the need of version control, the types of version control, benefits, and some basic concepts of the Git. So what is version control system and why should we care about it? Everyone who has ever written code must have had days where they maintain different version of their files. Whether it is adding documentation to your code, rearranging the methods, adding or removing some classes or resources, we all have maintained several versions. And generally, how do we do it? In normal scenario, what you might be doing, you will just keep several copies of that file with different nomenclatures. Naturally, you must have wished for an organized way of storing these versions to see progressive changes made to the code. And additionally, if one is working in a team with multiple people working on different features, then maintaining versions of all features quickly turns into a nightmare. So, version control, which is also known as revision control or source code, is a component of software configuration management. That is, the management of changes to documents, computer programs, large websites, and other collection of information. You can think of version control as a kind of database. It lets you save a snapshot of the complete project at any point of time. Second, every change made to the project files is tracked along with who made the change, why they made it, and reference to problem fix or enhancement introduced by the change. Changes are usually identified by a number or letter code which is termed as the revision number. This revision number, which can also be called sometimes as revision level or simply revision, is a unique ID. For example, initial set of file is revision 1, and when the first change is made, the resulting set is revision 2, and so on. Now this is generally a label that I am giving, revision 1 in revision 2. Actually, in real scenario, it will be a very long hash string which will be unique ID to identify our changes. Last point is it allows you to revert selected files back to a previous state or revert the entire project back to a previous state. We can also compare changes over the time to see who last modified something that might have had caused a problem or who introduced an issue and when and more things. Why we need VCS? As we discussed in the first slide itself, that when we're working on different versions of files and we are working in a remote environment with different developers collaborating in our project, then it might become a problem in the sharing mode. So without a VCS in place, you're probably working together in a shared folder on the same set of files, which is extremely error prone, and sooner or later someone will overwrite someone else's changes. With VCS in place, everybody on the team is able to work absolutely freely on any file at any point of time. The VCS will later allow you to merge all the changes into a common version. There is no question where the latest version of a file or the whole program is. It is in a common central place, your version control system. So for example, in this scenario, we have a common repository of code and we have multiple developers contributing to it. So developer 1 is working on new feature 1, while developer 2 is working on new feature 2 in parallel, and the developer 3 in parallel is working on some bug fix. So with VCS, this is possible. There are many advantages of VCS. Number 1, it maintains history of changes. A version control system acknowledges that there is only one project. Therefore, there is only one version on your disk that you are currently working on. Everything else, all the past versions and variants, are neatly packed up inside the VCS. So when you need it, you can request any version at any time and you will have a snapshot of the complete project right at hand. Second, it is easy to roll back. Wrong check in the comment. Now, being able to restore all the versions of the file or even the whole project effectively means one thing: you can't mess up. If the changes you have made lately prove to be garbage, you can simply undo them in a few clicks. Now, knowing this should make you a lot more relaxed when working on important bits of project, because in case there is no, for example, consider a scenario if you are unable to roll back and if I commit something wrong, then I'll have to actually make changes and then again recommit it. Or for example, this is the scenario that I always take. If I'm working on features, then I'll push small commits, or I'll just push small changes in my repository. Now this helps me also to refactor the code, because when the code is very large, then we always shy away from refactoring it because we think that we might break something. So all these scenarios, rollback becomes very important. Number third, adding comments after making changes helps identify reason for a change, which means that every time you save a new version of your project, your VCS requires you to provide a short description of what was changed. This helps you to understand how your project evolved between the versions, and it also helps others to see what has been pushed into the repository. Version control also prevents conflict by giving us tools to resolve the overlapping changes. It also enables multi-user development and testing in parallel. As I said, that it is a great way to keep track of application builds by being able to identify which version is currently in development, which is in QA, or which is in production. Now, what is a snapshot of VCS? So, a snapshot is generally a collection of VCS configuration files backed up at a particular point in time. It also contains information such as snapshot name, description, creation time, and file permission. In other words, snapshot, especially in Git, are synonymous with commits. So every time you commit something to a Git repository, you are saving a snapshot for all the files in your repository. And Git is not saving all files tracked by your repository every time you commit, as you might imagine that you might be doing if you were to physically take a picture of them. Instead, each commit, Git saves the changes from the previous commit. So when you do a Git checkout, which we will later see in the project what it means. So every time we are getting a new version through this command, the Git checkout, a particular commit, the Git reconstruct this complete snapshot of the code by starting with the first commit and applying all the changes leading up to the last commit. So you see, we're just keeping the differences of these snapshots. So for example, this is the screenshot of a commit. We can clearly see we have a date, which is this committed on September 21, 2018, while the second last commit is committed on May 30th, right? We also have comments, which is this commit was made to update the readme.md file, while this was made to update local repository. This was again on May 30th, which is adding new features. And this is my unique ID, right, that we talked about. So this is some hash code which is unique. This is the branch which you will again see in the coming slides. What does it mean? It has logged the complete snapshot of the system with information of who made the changes on what time and what were the comments, what files were updated, so on. Now this is the detail of each and every commit that has been made. For example, this is the detailed version of the get me readme file. We can also see the differences, which will cover this in detail, but this is for the reference for now. So let's move to the types of version control system. So there are two types of version control. One is the centralized VCS and the second one is distributed VCS. With centralized version control system, you have a single central copy of your project on a server and you commit your changes to the central copy. You put all the files that you need, but you never have a full copy of your project locally. So some of the most common version control systems are centralized, including SVN and Perforce as another. SVN is for subversion. While with distributed version control, you don't rely on central server to store all the version of a project's file. Instead, you clone a copy of a repository locally so that you have the full history of the project. Now, two common version control systems are Git and Mercurial. Here again, these are some terminologies that we'll be using throughout this project. Number one is repository, which is a collection of commits and branches and tags to identify the commit. We'll cover in later phases that what is a commit actually, what does a branch mean, and what are the tags. But we can also think of it as just simply as a collection of files which are managed by Git or any version control system. Second is the workspace, which is where you do your actual work. It contains the tracked files, untracked files, and a special directory. So all the project that we are working on, which is residing in the repository, is called as workspace. Workspace can also mean different things in development version, but in terms of VCS, we mean, for example, if it is a Git project, then we can think it of as a workspace in VCN terminology. Now let's move a bit deep into centralized VCS. How does it work? In centralized version control, each user gets his or her working copy. But there is just one central copy, which is residing on the repository. So as soon as, for example, in this scenario, we have one central copy and different working copies, which are residing on different workstation or PCs. Now, as soon as you commit something, which is you made some changes in it and then you are pushing them to the repository, it is possible for your coworker to update and see your changes. Now, how do they do that? Once you commit it, then your coworker will update his repository. Once they update the repository, they will have your changes pushed to their system. So for others to see your changes, two things must happen. Number one, you must commit something, and number two, they update it. Now here are a few insights on the centralized VCS. So number one is that they have a single server which stores all the file. Single server, by a single server I mean the central server, which will store all the file and will have the collaboration across the teams. Second, there is a single point of failure, which means that if there is an error, it can destroy all the build. Number third, in a worst case, if the disk or central server gets corrupted and the proper backup has not been taken, then you will lose the entire history of the project. Now let's move to the distributed VCS and understand how does it works. So these systems do not rely on central server. So instead, each developer will clone a copy of the repository, which is here, and has the full history of the project on their own hard drive. Now this copy has all metadata of the original project, which is the residing on a remote server. So each developer clone the main repository to their local system, and developer can create another branch or can directly work on local repository. I have been using the term branch again and again, but we will explain it and see in more detail when we move ahead at what does a branch mean and what advantages does it provides us. So what is happening here is that my central repository, I have a working copy on different workstations, different copy, 3 different copies, and each copy will contain the full history of all the changes. So once the working copy, what developer will do, they will make the changes to the working copy and commit the code to the local repository. This is by local repository, I mean the repository residing on my system. Now once it is in the local repository, then I can decide to push the code to the remote repository. Now you see the difference. Here we are using the term commit to the local repository and we are saying pushing to the remote repository. Now at this point of time, once you have committed in the repository, you can also decide to pull from the server or to rebase your changes. By rebase I mean discard your changes. Once you have pushed it, then other developers can pull these changes from the remote repository to update their personal repository. This is similar to what we saw in the centralized system, that you commit something and then you update your system. While here it is, we have one more layer, which is the local repository, wherein we commit to local and then we push to the remote, and once it is pushed, then we pull it back onto a system. Now here's some insights on the distributed version control system. Number one, there is a backup, as all developers have a local copy, which we saw in the last figure. Number two, every checkout is a full backup of the repository, including the metadata. Number three, it enables offline commit, branch creation, and so on, because you will always be working on the local repository. And once your commits are there, then you can decide to push them all in one go on the remote repository. This has certain benefits as well, which we will discuss in the coming slides again. Now we have understood that there are two types of version control system. One is distributed and one is centralized. Now Git is a part of distributed version control system. So let's look more deep into what the Git actually is. So Git is by far the most widely used modern version control system in the world today. It is an example of distributed VCS, and it is mature, actively maintained open source project which was originally developed in 2005 by Linus Torvalds, who was the famous creator of Linux operating system kernel. It works well on wide range of operating system and IDEs. And being distributed also enables significant performance benefits as well. So I'll give you a quick example of it. Now let's say a developer X makes changes to source code, adding a feature for the upcoming 2.0 release. Then commit those changes with descriptive message. So far, we have pushed the message to the local repository. Now the developer then works on second feature and commit those changes too. Naturally, these are stored as separate pieces of work in the version history. For example, someone will have a different commit ID and other one will have a different commit ID. Now X then switches to a version 1.3 branch. From 2.0, it is switching to 1.3 of the same branch to fix a bug that affects only the older version, which is 1.3. So the purpose of this is to enable X team to ship a bug fix release before the 2.0 is completed. Now X can return to 2. Once this is committed and pushed, then X can return to 2.0 branch to continue working on new feature for 2.0. And all this can happen without any network access. Except the push part, all this can happen without any network access and is therefore fast. So why is it fast? Because I'm not going to the my remote repository again and again, but what we are doing, we are pushing everything on the local, even the branch switch. And once we have our changes, we then pushing them to the remote, or once we come into a network, we then push them in a remote in one go. Now Git has been designed with integrity of managed source code as a top priority. So what it means is that the content of files as well as the true relationship between the files and directories and all these things are secured with a cryptographically secure hashing algorithm called SHA-1. Now this protects the code and change history against both accidental and malicious changes and ensure that the history is fully traceable. And there's the last one is that unlike some version control system, Git is not fooled by the names of the files. What it means that when determining that what the storage and version history of file should be, Git focuses on the file content itself. So we're not just relying on the history, but Git will make sure that if the file has been changed, then it is reflected as an updated one. Now, since Git architecture has a local copy, hence most operations are on Git are local, which is again the reason for it being fast. So once the Git commits are done, users will push the changes to remote repository. Hence, very few commands require network connection. It is open source and free. It can be easily integrated with other software tools through Git add-ons such as Zira, which is a highly popular bug tracking and issue tracking tool. And last, with simple steps, Git can be configured to work as a centralized version control system if need be. So why we need Git? Now, any VCS can help you track all the changes with your project in order to keep track of the changes. It can help you see who edited the file, what has been changed, and how to roll back or revert the code if necessary. So Git or any version control system will actually takes care of all these things. Spend Git is, as I said, is the most popular one. So what Git can do, it can help you recover the whole project or a single file, number one. Second, it can help to revert the changes in case you break something. Now this is also a great way to experiment with the code. As I said in the past as well, my strategy is that I commit small features or part of the features when they are completed in my repository, and then if refactor is required, then I experiment with the refactor and do it. And if it does not work, then I'll just roll back it right away. Number three, in your Git repository, other developers can clone it and then they can also start contributing to it in parallel. Number four, all the Git commits along with comments can be viewed via the history. So the entire history is available with me. And the last one is, since we have a local and remote repository, hence code can be backed up, which is not the case in the central VCS. Now here are some typical use cases of the Git. For example, we have a developer Alex who is working on new feature which needs to go for 2.0 release. He commits his changes and then Alex switches to the branch version 1.2 of the same software to fix a bug fix. Once that is done, Alex can then return to 2.0 branch to continue working on the new feature. To do all this, network access is not required. Why? Because we already have a local repository that includes all the metadata and everything. Alex can commit all the changes without a network, and once that is it all has been done, and when the Alex gets into the network area, then Alex can commit all the changes to remote repository, or I should say push all the changes to remote repository in one go. So this is again the same example we're getting, that we have different versions that we are working on in parallel. We are working on version 2.0 on new feature, and we are working on version 1.2 on bug fix. The only thing we have to do is switch between the branches, which can be very easily done in the Git. So we have been using the term Git branches a lot. Let's look into it, that what does a branch mean. So a Git branch is essentially an independent line of development, which means that you can take advantage of branching when working on new features or bug fixes, because it isolates your work from that of other team members. Branches serves as an abstraction for the edit stage commit process. You can think of this as a way to request a brand new working directory, staging area, and a project history. Now, Git branches, when we create a branch, they do not generally contain files. Rather, branch names like master or dev or xyz, anything, they just store a commit hash ID, which is the unique ID that we have been talking about. Git branches are effectively a pointer to the snapshot of your changes. If you remember, we just discussed the snapshot in the back. So what it means is the name of a commit or any other Git object is written as a 40-character hash ID. Now these hash ID are impossible for us to use in any practical way. So what good Git provides is a method of turning a short meaningful name into a big ugly hash ID. Now these names may come in many formats, but the first one you use is a branch name. When you want to add a new feature or a bug fix, right, no matter how big or small, you can spawn a new branch to encapsulate your changes. This makes it harder for unstable code to get merged into the main code base, because we have a different code bases now which are working in isolate. New commits are logged in the current branch history. Whatever we commit, they will be logged in the current branch. Now, once that is done, then we can merge them independently, or we can merge them two branches later on, which we'll again see in the coming slides. There is again some branch terminology. Now, commit is a command that records changes in the current branch. If I do git commit and the files, the commit will happen on the current branch, while branch is a pointer to one of the commits. As I said, branch is not saving actual files, but it's just a pointer to the commits, and commit is identified by the unique hash ID. Checkout is another command which is used to create a new branch, or not actually create a new branch, but it is actually used to switch to an existing branch. For example, as I said, master is the default branch that you will have, and in addition I'm creating a new branch dev, and if I'm on master, then what I'll do is I'll just do git checkout dev and I'll switch to that checkout branch. And again, master is the default branch, as I said earlier. We use git push to push commits made on your local branch to a remote repository, while pull is the opposite, which is used to fetch and download contents from a repos repository and update the local repository to match that content. There are two more terms which are conflicts and the reset. Now, in version control system, all the version control system, not just Git, they are all about managing contributions between multiple distributed authors, which are usually developers, let's say. So sometimes multiple developers may try to edit the same content or the same file, and if developer A tries to edit content that developer B is editing, then a conflict can occur. So conflict means, as the name suggests, is some person has committed it and we are actually working on it, and then we see that and it is not updated on our end, then we might see there is a conflict. Now, in case of conflict, in case there is a merge conflict, then a reset can be used to undo the changes to the working directory and the staging area. We will see what the staging area is, but we already know what the working directory is. So we can reset can be used to undo changes to the working directory, changes that we have done. Now in this figure, what is happening is that we have different branches on the timeline. This is our master branch, the yellow one, and we have different branches. So for example, we have a master branch little on the master. After two commits, we created a new branch little feature, and we also keep on continued the development on the master branch, and once after at this point of time, what we did is we merged the little feature branch into the master branch, and after that we created another a new branch which is called as big feature. Now if you see here, the big feature branch is now ahead of the master branch because the version or the work is still in progress, it has not been committed, while in little feature branch the work is completed, hence we merged it back to the master branch. Now let's look at their other VCS tools that are available in the market and are pretty popular. So concurrent version control system, which is called a CVS, is a free client server revision control system. It is a centralized VCS. Second one we have is Mercurial, which is again a free distributed source control management tool. So Mercurial's major design goals include high performance and scalability, decentralization, fully distributed and collaborative development, etc. We also have Apache's Subversion, which is often abbreviated as SVN. So this is a software versioning and revisioning control system distributed as open source under the Apache license. This is also very popular. But if you remember from our slides when we discussed distributed and centralized, then this is a centralized version control system. So there are some differences between the Git or the SVN and VCS. One is distributed, one is centralized. Difference is simple, that distributed is means that we have a local repository of the changes. Centralized means we have only one repository. This can work on offline since we have local repository, and this cannot. We have a complete local history because every time we clone a new branch, we get all the metadata along with it, while this is not the case with SVN. This is fast because we are not doing network operations every now and then, and this is slow. Again, this is lightweight because of the same reason, that why Git branches lightweight, because they are simply pointers. So Git just points master or development or any branch name at a particular commit, while in SVN every branch is a full copy of the repository including all the directories. Now we have complex tags here in Git, while we have simple tags in SVN. Now in Git, why it is complex? Because it is a pointer, while in SVN it is a copy of all the directories. In Git, rebase patches can be rebased easily. So what does rebase mean in the Git? In its simplest form, it is a command which will merge another branch into the branch where you are currently working, and it will move all of the local commits that are ahead of the rebase branch to the top of history of that branch. Forking means creating a copy of the repository, which is like very difficult in SVN. Same is merging. Merging is that when we have two branches, then we are merging them together, which is pretty easy and one of the USPs of Git. Git is more secure and SVN is less secure. Security in the terms of the, as we said, that if you remember the few times we talk about the SHA one that they have been used in the past. Here are some benefits of the Git. One, it is fully distributed, so developers can work on in parallel in different branches, in which means they can work in an isolated environment. Non-linear development support, which is again the Git branches, that they can work on multiple branches in parallel. They are efficient because they are able to handle large projects like the Linux kernel efficiently. They are faster because distributed in nature. There is no load on a single server, same as with the web-scale architecture that we see. The design is simple because there is no centralized repository and everybody can work freely. Now let's look at when to use Git and when not to use Git. So we have already seen some benefits of Git, but let's look at the different scenarios. Now when the scenario one is the developer wants to work freely and independently. Then since every developer has its own local copy of the repository, which is in by nature of the Git, then they are not anxious about losing the data or harming the repository. They can work on it freely and they can even commit it. Once they have committed to the local repository, then and they are sure of it that it is working fine, then they can push on to the remote repository. If anything goes bad in between, then they can pull again, they can rebase their branch and they can pull again from the remote repository. There's another scenario, the team wants to make code management faster and quicker. So this is again the Git supports two types of, there are out of many interfaces, there are two interfaces that are discussed here, which is Git command line interface and the GUI interface, which are again very fast and take very less execution time as compared to other VCS. Now this using this command line interface or using the GUI interface depends on the preference, but if you're a developer, then I'm very sure that the command line interface will be much useful for you. And then we will also see in the next module maybe that the command line interface has only command line interface will allow you to execute all the commands of Git, which might not be the case with GUI. Now there is another case that there is a requirement of working on multiple branches simultaneously. So these all reference multiple branches. Now we already see what the branches are, so they are just pointers to the entire Git system. They are just pointers, which makes it very lightweight and easy to create. So it is not that if I create multiple branches, then I might run out of disk space or maybe I might create some performance overhead. No, they are very lightweight, and no matter how many branches I create, and every branch is independent, which means that every developer can work in isolation. The next scenario is team wants to have ability to work offline, which is only possible in the Git. because that Git is a distributed VCS. Not only in Git I should say, but I should say that it is only possible in distributed VCS, which is possible in Git, because we have a local repository and we can work on in parallel, and once we get in the network we can push over all the changes in one go. There's another scenario: the team needs a VCS having fault tolerance. So what it means is that all the tasks can be undoable. Undoable means if we have committed something, then we can revert all the commits or our changes very easily. And since Git checksums before starting the file, make sure, which means that if there is any file and we have made any changes in it, then Git will always identify it. It won't be that they will go unnoticed. So this is the way the fault tolerance will happen in the Git. Now, when not to use Git, there might be scenario that when you won't want to use Git. So number one is that when developers like to work at slow pace and they don't want to commit incremental changes, rather you want to commit as a whole, then Git is not for you. But trust me, once you are committing the incremental changes, this is where your project will be more manageable. Teams are habitual to work in centralized system and they are not familiar with distributed one, then you should continue work, and you don't want the risk involved in it, so you should continue working on the centralized system. Now Git performance may tend to decrease when dealing with large size files. So if you have very large size files, you should consider using, give it a thought whether you want to use Git or not. However, there are additional extensions that you can use to solve this issue. The last one is that the project scope is very less and you will have just 2 branches. Now it is not that you should not use Git, but Git won't provide you the complete benefits, because the main USP of the Git lies in the branching or working in parallel. We are discussing the web scale architecture on which the Git is also based. Web scale architecture will be more suitable when we are thinking of keeping our repository in the cloud, which is the case with the GitHub. So this is pioneered by the different cloud providers or the web companies such as Google, Amazon, and Facebook. Now here all the metadata and all the data in the metadata is distributed across the cluster. Now cluster is a group of computers which are, they can be small or they can be large. If this is small, then it will be called a small cluster or distributed cluster. So cluster means a group of computers which are working together. They can be remotely situated or they can be situated in a single rack in your lab, server lab. They can have a single rack or they can be multiple racks or they can be multiple server labs across the locations for you. So what this web scale architecture will do, it will eliminate the resource contention and will enable the scalability without limits. Now this is again the scenario, or this is again the scene behind the big data architecture that is happening these days. So this plays a very important role if you want to use Git at large scale in your organization. For example, large objects or large number of objects or the large number of repository. Now GitHub is again an example of this web scale architecture. Now few organization, for example like Microsoft, they have built on top of Git like GVFS. So GVFS, which is called as Git virtual file system, is an open source system that enables Git to operate at enterprise scale. It makes using and managing massive Git repositories possible, right? If you remember, this is one of the disadvantages we mentioned. Now GVFS virtualizes the file system beneath your Git repository so that Git tools see what appears to be a normal repository, when in fact the files are not actually present on the disk. GVFS only downloads files as they are needed. GVFS also manages the Git's internal state so that it only considers the files you have access. Instead of having to examine every file in the repository, you only examine the files that have been accessed. This ensures that operations like status and checkouts are as fast as possible. So this is the GVFS. For example, here if you will see that now this is on the repository and we are only downloading the files that we have changed. So we have selected access to the files. Why use GVFS? Number one, Git struggles to handle enterprise scale repositories, as we said again in the past as well. So operations like cloning will slow to a crawl when you have millions of files in the repository, and something as simple as getting your repository status will leave you waiting. So GVFS can be a huge advantage. Second, it is freely available and open source. Third, if your team and your code base are growing to enterprise scale, then GVFS may be a great fit because it enables Git to manage and use the massive repositories. In this module, what we understood is we looked at what is version control system. Now we understand it very well, that there are two types, centralized and the decentralized. We know what is Git. We know what are branches, which is again I'm saying the USPs of the Git. We know the benefits of Git. We have discussed different scenarios when to use Git and when to not to use Git. We also looked at GVFS, which is a Git virtual file system, which will help us to make Git even faster when we are dealing with massive amount of repository or repository with like millions of files. All those source scenarios, GVFS will be a great fit for us. Thank you.